Good morning, my dear students. So after the completion of limits, I am going to start continuity. So if you are thorough in limits, then this concept and also problems you can understand easily. Okay. So when we say that a process is a continuous process, if there is no break or gap in that process. In the same way, when we say that a function is a continuous function, if the graph of the function has no break or gap or any hole, then only that function is continuous function. So it is a geometrical meaning of continuity of a function. Geometrical meaning of continuity of a function is what? If there is in the graph of the function, if there is no break or gap or hole. Okay, it is the geometrical meaning. Okay, next to, if we observe these 6 cases, I am considering these 6 cases. Observe these 6 cases. So in first case, the function is continuous at x is equal to a. First case, the function is continuous at x is equal to a. In the rest of the cases, the function is not continuous at x is equal to a. Why? So just go through the graphs. Here, when x is tending to a from left side, this is the left hand limit. The left hand limit is same as the value of the function, and the right hand limit is this part. When x is tending to a from right side, the function value tending to this value. So here LHL is equal to f of a, but not equal to RHL. Next here, LHL not equal to RHL, but RHL is equal to what? F of a. So in these two cases, LHL not equal to RHL, that means limit does not exist. Next, consider the fourth case. Here, both left hand limit and right hand limit both are exist and they are equal, but the function is not defined at a. So it is not continuous. Next, here it is not continuous because observe, both left hand limit and right hand limit both are equal, and f of a is also defined, but f of a is different from limit of the function. So function is discontinuous at a. Now observe this case. When extending to a, either left side or right side, the function value is tending to what? Infinite. The function value is tending to what? Infinite. So function is discontinuous. These are the reasons. In first case only the function is continuous. In the remaining 5 cases the function is discontinuous. Okay. So what is the mathematical definition of continuity of a function? Okay. So mathematical definition. So a function f of x or f is said to be continuous at x is equal to a. Continuous at x is equal to a if limit of the function is same as value of the function at a. So, and that is equal to some finite quantity. Okay. Limit of the function is equal to value of the function, and that should be finite quantity, should not be infinite. It should not be infinite. It should be finite quantity only. So limit of the function is equal to value of the function and should be finite quantity. See here, if this dot will come here, it should be continuous now. That means limit of the function should be equal to what? Value of the function, and should be what? Finite quantity. Or limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a, that is equal to some finite quantity. Okay, that means left hand limit is equal to right hand limit is equal to value of the function is equal to some finite quantity. So a function f is said to be continuous at x is equal to a only if limit of the function is equal to value of the function that is equal to some finite quantity, or LHL at x is equal to a, left hand limit at x is equal to a, RHL at a, right hand limit at a is equal to functional value, that is the value of the function at a, and that should be equal to some finite quantity. So it is a mathematical definition of the continuity of a function. Okay, and some important note points observe. So if f is continuous at x is equal to a, if f is continuous at x is equal to a, then compulsory limit should be exist. See this example only here, limit of the function at a is exist because the function is continuous at a, hence limit is exist. But converse need not be true. That means if limit is exist, it is need not be continuous at x is equal to a. If limit of the function at a is exist, it is not necessary that the function should be continuous at x is equal to a. Example 4 and 5. In 4 and 5 both cases limit is exist, but it is not continuous function. Here why it is not continuous? Because the f is not defined at a. Here why it is not continuous? Because here the limit is not equal to value of the function. Okay, so if f is continuous, then limit of the function is exist. But if limit of the function exists, it is not necessary that f is continuous at that point. And also, if f is continuous at x is equal to a, then f is defined at x is equal to a. Okay, but if f is defined at x is equal to a, it is not required that f is continuous at that point. If f is continuous at a, then f is defined at a. But if f is defined at a, it is not required that f is continuous at that point. For example, fifth case. Here f is defined at a, but it is not continuous at a. Okay. Next. Next I am discussing left continuous and right continuous. So I am writing simply, okay. So if left hand limit of the function, that means f of a minus is equal to value of the function, if left hand limit is equal to value of the function, then we say that f is left continuous. F is left continuous at x is equal to a. And if right hand limit is equal to value of the function, then f is right continuous at a. Right continuous at x is equal to a. So if you want, you can take the example 2, example 3. One is left continuous at a, other one is right continuous at a. And moreover, greatest integer function, step x. It is a right continuous at all integral points. Okay, but it is not left continuous. That is why it is not continuous at integral points. That means f is continuous at a if and only if it is both left continuous and right continuous. If it is only alone right continuous, it is not a continuous function at that point. Example same, step x function is right continuous at all integral points, but it is not left continuous. That is why at all integral points step x is discontinuous function. Next point, continuity of the function in an interval. So first I am taking interval, open interval a comma b. So a function f is said to be continuous in this interval, open interval a comma b, if f must be continuous at each and every point on open interval a comma b. If it is continuous at each and every point on open interval a comma b. If it is fails to continuous at least one point on open interval a comma b, then we say that f is discontinuous on open interval a comma b. So just like our exams, if we are getting pass, if all exams are pass, then only result is pass. Suppose if you are fail at least one subject, what will be the result? Fail. So your pass is nothing but continuous, fail is nothing but discontinuous. So if it is continuous at every point on open interval a comma b, then f is continuous on open interval a comma b. If it is fails to continuous at least one point on open interval a comma b, we say that f is discontinuous on open interval a comma b. So it is not necessary. So this is true. This is true on any interval. If you take any interval, if it is fails to discontinue, if it is fails to continuous at least one point in that interval, given interval, then in that given interval the function is discontinuous. Next. So at each and every point should be continuous. Then only f is continuous on open interval a comma b. If it is continuous at each and every point on open interval a comma b, then only f is continuous on open interval a comma b. Next, closed interval a comma b. So a function f is said to be continuous on closed interval a comma b. First, it should be continuous on open interval a comma b. That means it is continuous at each and every point between a and b. Second point, it should be right continuous at a. It should be right continuous at a. Because this function defined on closed interval a comma b. On closed interval a comma b. So this function is defined only right side of a, but not left side of a. So then the limit of the function at a is same as right hand limit. Now that right hand limit should be equal to what? Value of the function to so only we can say that it is continuous at a. So right hand limit of a is equal to value of the function at a means what? Right continuous at a. It is right hand limit f of a plus is equal to value of the function f of a. And similarly at b, if you observe, the function defined before b but not after b. So this function is continuous at b only when if it is left continuous at b. So left continuous at b. So f of b minus is equal to f of b. So a function f is said to be continuous on closed interval a comma b if it is continuous at every point between a and b, right continuous at a and left continuous at b. Okay. Next, the third one, domain. See, if f is continuous function, if f is continuous at each and every point in the domain of the function, if a function f is continuous at each and every point in its domain, then only we can say that the function is continuous function. Otherwise, it is discontinuous function. Okay. So the examples for functions which are continuous functions: all trigonometric, inverse trigonometric functions, next polynomial functions, rational functions, exponential functions, logarithmic functions, all these functions, mod x function, and next constant function, identity function, all these functions are continuous functions in their respective domains. So these are the examples for continuous functions. Okay. Next, for this one more example, point functions. So point functions are also continuous. So what is point function? Means the function which is defined only at one single point. So such functions are point functions. And point functions are always continuous. So point functions are also continuous functions. Okay. So example for point functions, suppose f of x is equal to, if I take square root of minus x square. So this function is clearly defined only when x value is 0. For other x values it is not defined. So what is the domain of this function? Only 0. And at 0 this function is a continuous function. Next, one more example. Square root of x minus a plus square root of a minus x. A is some real number. And this function domain also, what is the domain of this function? A. So this function is also defined only at single point a. So this is also point function. So point functions are continuous functions. Okay. Next, a function is said to be continuous everywhere. A function is said to be continuous everywhere if it is continuous on set of real numbers, on capital R. What is capital R? Set of real numbers. So a function is said to be continuous everywhere if it is continuous on capital R, where capital R is what? Set of all real numbers. And examples for though a continuous functions which are continuous, the continuous functions which are, continuous functions, I am considering those continuous functions which are continuous everywhere. So I am considering those functions which are continuous everywhere. For that examples, polynomial functions, all polynomial functions are continuous everywhere. Next, exponential function a power x, continuous everywhere. Trigonometric functions sin x, cos x, only these two functions, sin x and cos x, only those two functions only, continuous everywhere. And mod x function, continuous everywhere. Constant function, continuous everywhere. Okay. Next one important point. So if f is continuous, then f inverse must be continuous only. Okay. If f is continuous, then f inverse must be continuous. But if f is discontinuous, then f inverse may be continuous or discontinuous. So it may be continuous or it may be discontinuous. Okay. If f is discontinuous, f inverse need not be discontinuous. But if f is continuous, f inverse must be continuous. Okay. Next one, reasons for discontinuity. Reasons for discontinuity. So a function f is discontinuous either limit of the function does not exist. A function f is discontinuous either a function limit of the function does not exist, or limit of the function exists but it is not equal to f of a, or f of a is not defined. Okay. A function is discontinuous. What are the reasons for that? Either limit of the function does not exist. Second reason, limit of the function exists but it is not equal to value of the function. Or third reason, the function is not defined at that point. The function is not defined at that point. Okay. So to understand this, I am going to draw one graph. So consider this graph. So clearly from this graph the function is defined on set of non-negative real numbers, that is left closed right open interval 0 comma infinity. Okay. Now I am checking the continuity at 0. Continuity at 0 is nothing but what? It should be right continuous at 0. Check. So when x is tending to 0, from right side function value tending to what? 1. Also value of the value of the function at 0, 1. So when x is tending to 0, from right side the function value tending to what? Number 1. And also value of the function at 0 is also 1. So the function f is continuous at 0. And what about 1? The function is discontinuous because left hand limit not equal to right hand limit, but right hand limit is equal to what? Value of the function. That means at 1 it is not left continuous, but it is right continuous. See, when extending to 1 from left side, function value tending to what? 0. And when x is tending to 1 from right side, function value is tending to what? 1. So LHL is 1, 0, RHL is 1. Also value of the function is at 1. Left hand limit is 0, right hand limit is 1, and also it is equal to value of the function. So it is not left continuous, but it is right continuous at 1. So that's why it is discontinuous. Now f is discontinuous at 3 because here see left hand limit is same as right hand limit at 3. Both are equal to what? 2. When extending to 3, either left side or right side function value is tending to what? 2. But value of the function at 3 is what? 3. So your limit is exist, but it is not equal to value of the function. Hence it is discontinuous. Next, the function is continuous at 4 also because when extending to 4 from left side or right side, function value is tending to what? 1. Also value of the function is 1. So the function is continuous at x is equal to 4. And next, also at 2 also the function is discontinuous because left hand limit is equal to right hand limit, but the function is not defined at 2. Left hand limit is equal to 1 at 2. Right hand limit at 2 also 1 because when extending to 2 from left side, function value is tending to what? 1. When x is tending to 2 from right side, function value tending to what? 1. But the function is not defined at 2. So it is discontinuous at 2, discontinuous at 3, discontinuous at 1, but it is continuous at 0. Next, what about continuity at 5? It is again discontinuous at 5 because limit of the function does not exist, because when extending to 5 from left side, function value tending to plus infinity. And when x is tending to 5 from right side, function value tending to what? Minus infinity. So limit does not exist. So f is not continuous. Okay. And also, what is the limit extends to infinity f of x here? Yes, it is 0. See here, when x is tending to infinity, the function value is what? Closer to x-axis. That means that function value is closer to 0. Okay, because this going to become a tangent. This curve may be going to touch the x-axis at infinity. Okay, that means your x-axis is the asymptote. Also, this x is equal to 5 also asymptote. I think you understand this graph. If you can understand this graph, then you understand the concept. So next, I'm going to discuss some problems. So in the next session, I'm discussing problems. Thank you.